January 15th, 1945. Houffalize, Belgium. The metallic screech of treads on frozen cobblestone stopped abruptly as Hauptmann Friedrich Weber's Panther tank shuddered to a halt. Through the commander's cupola, he watched with growing disbelief as another American Sherman tank, the fourth one his crew had disabled that morning, simply refused to die. They had hit it 3 times. 3 75mm armor-piercing rounds from their superior Panther gun, each one penetrating the Sherman's thinner armor. According to every tactical manual, according to 2 years of combat experience on the Eastern Front, that tank should have been a burning wreck. Instead, through his commander's periscope, Weber watched American crewmen bail out, 2 of them wounded but walking. The Sherman sat there, engines still running, smoke pouring from hatches, but structurally intact. And most disturbing of all, within 20 minutes, an American recovery vehicle was already hooking cables to it. "They'll have that back in action by tomorrow," his gunner, Unteroffizier Hans Müller, muttered. "I've seen it happen 5 times now. We destroy their tanks, they repair them overnight. We lose a Panther, it's gone for weeks." Weber didn't respond. He was calculating something that made his stomach turn. In the past 3 days of fighting, his company had knocked out approximately 30 American tanks. But every morning, the Americans seemed to have just as many as the day before. Meanwhile, his own company had started the Ardennes offensive with 18 Panthers. They now had 7 operational. What Weber couldn't know, what no German tanker yet understood, was that they weren't just fighting American tanks. They were fighting an entire industrial ecosystem that had transformed warfare itself. A system where the people welding armor plates in Detroit factories were as decisive as the soldiers firing guns in Belgian forests. The Americans had achieved something the Germans deemed impossible. They had made tanks disposable. Not because they were cheap or poorly made, but because they could replace them faster than anyone could destroy them. And the secret to this miracle wasn't better engineering. It was something far more revolutionary: the myth of German superiority. September 1939. Krupp Steelworks, Essen, Germany. Uber-Ingenieur Klaus Hoffmann stood before a Tiger I prototype, running his hand along the precisely machined armor plate. Each weld had been inspected under magnification. Each component had been crafted by master metalworkers whose apprenticeships lasted 5 years. "This tank is a work of art," he told the Waffenamt procurement officers. "Each one requires 300,000 man-hours to complete. The armor is case-hardened to specifications that would make metallurgists weep with envy. No American tank can match its protection or firepower." Everything Hoffmann said was technically true. The Tiger I, entering production in 1942, represented the pinnacle of German engineering philosophy. Its 88mm gun could penetrate any Allied tank at ranges exceeding 2,000 meters. Its armor, up to 100mm thick on the frontal arc, was virtually impenetrable to most Allied weapons. Production began at Henschel's Kassel plant, using methods that would have been familiar to medieval armorers. Master craftsmen hand-fitted components. Welders with decades of experience created joints stronger than the base metal. Quality control inspectors rejected entire assemblies for microscopic flaws. The result was magnificent. It was also catastrophically slow. In 1943, Germany produced 649 Tiger I tanks. In 1944, production peaked at 623 units. By contrast, American factories that same year would produce 17,565 Sherman tanks. But German engineers dismissed these numbers. "Quantity is the refuge of inferior design," Hoffmann wrote in a 1943 technical report. "1 Tiger can destroy 10 Shermans, therefore our production ratio is more than adequate." This calculation ignored a fundamental reality that would become horrifyingly apparent in the winter of 1944. Tanks don't just fight other tanks. They fight entire industrial ecosystems. And in that war, Germany was being buried alive. The American Revelation. December 1940. Chrysler Tank Arsenal, Warren, Michigan. K.T. Keller, president of Chrysler Corporation, walked through an empty field where corn had grown 6 months earlier. Beside him, William Knudsen, Roosevelt's production chief, spread out blueprints for a facility that seemed impossible. "You want me to build a factory larger than anything that currently exists, staff it with workers who've never seen a tank, and produce 1,000 tanks per month using assembly line techniques within 18 months? 16 months, Knudsen corrected. We don't have 18. What happened next represented a complete paradigm shift in military production. While German engineers obsessed over precision and perfection, American engineers asked a different question. How do we make acceptable tanks fast enough to overwhelm any enemy? The answer revolutionized warfare. Chrysler didn't hire master craftsmen. They hired anyone who could hold a welding torch. Housewives, farmers, teenagers, elderly workers. They took people who'd never seen industrial equipment and turned them into tank builders in 2 weeks. The secret wasn't skill, it was system. American engineers broke down tank construction into 15,000 discrete tasks, each simple enough that minimal training sufficed. They developed welding techniques that didn't require years of apprenticeship. They standardized components so completely that parts from Detroit factories fit perfectly with parts from Fisher body plants in Grand Blanc. Most revolutionary of all, they abandoned German obsession with perfection. Good enough became the philosophy. If a weld was 80% as strong as perfect specification required, and the tank still functioned reliably, it was acceptable. This single mindset change multiplied production speed by factors of 10. By August 1941, the Chrysler Tank Arsenal was operational. By December 1941, they were producing their first Shermans. By 1943, a new Sherman rolled off their assembly line every 48 minutes. The Welding Revolution. March 1942. Kaiser Shipyards, Richmond, California. Mary Henderson had been a secretary 3 months earlier. Now she was a shipyard welder, one of the Rosie the Riveters who would become American icons. But Henderson wasn't riveting. She was welding, using techniques that German engineers insisted were impossible for mass production. The Germans had concluded that only experienced craftsmen could produce reliable armor welds. Kaiser proved them catastrophically wrong. The secret lay in 3 innovations that transformed welding from art to science. First, automatic welding machines that produced consistent joints regardless of operator skill. These machines fed detailed specifications developed by metallurgists, created welds that exceeded German handcrafted quality while requiring minimal human expertise. Second, standardized welding procedures developed by the American Welding Society specifically for armor plate. These procedures, tested on thousands of sample joints, created a cookbook that any trained operator could follow. No artistry required, just methodical execution. And third, and most revolutionary, the acceptance of good enough welds that German quality standards would have rejected but performed perfectly adequately in combat conditions. Henderson and 10,000 workers like her weren't making art. They were making weapons. And they were making them so fast that German production couldn't compete. The statistics tell the story. A German Tiger I tank required 300,000 man-hours to complete. An American Sherman required 10,000 man-hours. This 30-to-1 efficiency ratio meant that for every hour Germany spent building one tank, America built 30. The Maintenance Miracle. January 1944. Forward Maintenance Area, Anzio, Italy. Technical Sergeant Raymond Morrison stood beside a Sherman tank that had taken a Panzer IV round through the turret. The German shell had penetrated the armor, killed the gunner, and exited through the opposite side. According to German maintenance protocols, this tank would require depot-level repair, removal from the front, transportation to rear area facilities, extensive reconstruction by skilled workers, estimated time 6 to 8 weeks. Morrison's crew had it operational in 4 days. The secret wasn't magic, it was modularity. Unlike German tanks where components were custom-fitted and required specialized tools to replace, Sherman components were designed for field replacement by mechanics with standard tools.
The turret? Completely removable unit. 4 hours to detach, drop in a replacement, reconnect electrical and hydraulic systems. The engine? Accessed through large rear doors, could be pulled and replaced in 2 hours by a trained crew using a portable crane. German Panthers required engine removal through the top, necessitating special facilities. The transmission? Modular design, replaceable in 6 hours. German transmissions were integrated systems requiring days of labor to replace. Most revolutionary, the weapons themselves. If a Sherman's 75mm gun was damaged, the entire gun mount could be replaced in half a day. German tanks required the gun to be removed, repaired at depot level, and reinstalled, a process taking weeks. Morrison's maintenance company could rebuild a completely destroyed Sherman using components from 3 damaged tanks in 48 hours. They did this routinely, under combat conditions, while being shelled. "We're not repairing tanks," Morrison told a war correspondent. "We're assembling them from parts, like building a car engine, only the parts weigh tons and people are trying to kill us while we work." The Industrial Mathematics. June 1944. Supreme Headquarters Allied Expeditionary Force, England. Lieutenant Colonel Simon Buckner presented statistics that would have seemed propaganda if they weren't meticulously documented. "Gentlemen, these are the production and maintenance figures for American armor in the European theater as of May 1944. The numbers told the story that German intelligence refused to believe. Shermans produced in U.S. factories, 49,324, total through war's end. Shermans lost in combat, 8,348 destroyed beyond repair. Shermans repaired and returned to service, 21,453. Average repair time for battle damage, 4.7 days. Average time for major component replacement, 8.3 hours. By contrast, German tank production and maintenance figures. Panthers produced total, 6,000 approximately. Panthers lost in combat, 4,200. Panthers repaired and returned to service, 800 approximately. Average repair time for battle damage, 30 to 45 days. Average time for major component replacement, 120 to 200 hours. The implications were staggering. For every Panther destroyed, Germany struggled to repair 1. For every Sherman destroyed, America repaired 3 and built 5 more. "The Germans are fighting a war of attrition they cannot win," Buckner concluded. "They're destroying our tanks faster than we'd like, but we're replacing them faster than they can believe." The Field Experience. December 16, 1944. Opening of the Battle of the Bulge. Corporal James Mitchell's Sherman tank, American Girl, took a hit from a German Panther at 07:15 hours. The 75mm round penetrated the right side armor, destroying the transmission and wounding the assistant driver. Mitchell and his crew bailed out as German infantry advanced. They expected their tank to be lost, written off, a statistic in somebody's after-action report. 48 hours later, Mitchell watched as a recovery crew from the 3rd Armored Division's Maintenance Battalion hooked cables to American Girl. They dragged her to a field maintenance area 5 miles behind the line.
By December 20th, Mitchell was climbing back into American Girl, now sporting a replacement transmission, new tracks, patched armor, and a coat of fresh paint over the repair work. "How?" he asked the maintenance sergeant. "Magic," the sergeant grinned. "That and about 500 replacement transmissions sitting in a depot in Liège. Your transmission came from a tank that took a hit in the turret 2 weeks ago. We pulled the good transmission, scrapped the hull, used the parts to fix 3 other tanks. You're driving a Frankenstein, Corporal. Half the tanks in this division are." This was the reality German tankers faced. They would destroy an American tank, consider it a victory, only to face the same tank or its identical twin days later. Meanwhile, their own damaged vehicles sat immobilized for weeks, awaiting parts that might never arrive. The German realization. February 1945. Tank Maintenance Depot, Paderborn, Germany. Hauptmann Weber, whose Panther had broken down for the 3rd time in 2 weeks, watched German mechanics struggle with the damaged transmission. "How long?" he asked. 2 weeks minimum, Herr Hauptmann. We're waiting for a replacement from Kassel. They're waiting for steel from Essen. Essen is waiting for coal from the Ruhr, which the Americans are bombing. Weber walked outside where 37 Panthers sat immobilized, awaiting parts, repairs, or fuel. His company was authorized 18 tanks. They had 7 operational. The other 30 represented accumulation of damaged vehicles they lacked parts to repair. Across the maintenance yard, he could see American prisoners working under guard. One of them, a tank sergeant, was examining a damaged Panther with professional interest. "You," he called in English. "How long to repair this?" The American sergeant studied the damage. "In a German shop? 2 weeks, probably. In an American maintenance unit, we'd have this back on the line in 3 days max. Pull the transmission, drop in a replacement, weld the armor patch, done." "But the precision," Weber protested. "The transmission must be precisely fitted." "Why?" the American shrugged. "Our transmissions are interchangeable. Any Sherman transmission fits any Sherman tank, period. You guys custom fit everything, which is impressive engineering but terrible logistics." Weber understood then the Germans had built superior individual tanks. The Americans had built a superior tank system. In a war of attrition, the system mattered more than individual quality. The production philosophy. July 1943. Fisher Body Plant in Grand Blanc, Michigan. Margaret Sullivan had worked at the plant for 11 months, welding Sherman holes on an assembly line that moved at precisely calculated speeds. Her job was simple: make 6 welds on each tank hole as it passed her station. Each weld took 45 seconds. She made 480 welds per 8-hour shift. She wasn't a master craftsman. She was a component in an industrial machine that produced 10 complete tank holes daily. Down the line, another worker installed the glasses plate. Another fitted the turret ring. Another connected hydraulic systems. Each task was simple, trainable in days, repeatable with minimal skill. This was the secret German engineers never grasped. You don't need master craftsmen to build tanks quickly. You need a system that breaks complex tasks into simple steps that anyone can perform reliably. Quality control happened through inspection, not individual craftsmanship. Random tanks were subjected to abuse tests that would horrify German engineers. Driven into walls at speed, fired upon with their own weapons, subjected to impacts that simulated worst-case combat conditions. Tanks that failed were analyzed. Weak points were strengthened in the design. Training procedures were modified. The assembly line improved continuously. German craftsmen would have been appalled by the casualness of it all. American engineers understood that good enough quality, produced faster, was superior to perfect quality produced slowly. By 1944, American plants were producing tanks so quickly that they began stockpiling them. Literally thousands of Shermans sat in depots awaiting shipment overseas. Germany, meanwhile, struggled to replace combat losses. The logistics triumph. March 1945. Port of Antwerp, Belgium. Colonel Thomas Morrison watched as Liberty ships unloaded their cargo. Tanks, tank parts, ammunition, fuel, and most importantly, entire replacement tank crews, trained and ready. "How many?" he asked the port officer. "Today? 240 complete Sherman tanks, plus approximately 5,000 major components, engines, transmissions, turrets, you name it, and 1,200 replacement crew members." Morrison did the math. In one day, through one port, America was delivering enough tanks and parts to equip multiple armored divisions. Meanwhile, German production across their entire remaining industrial capacity was producing perhaps 20 tanks daily. The logistics advantage extended beyond pure numbers. American supply chains were designed for interchangeability. A Sherman part made in Detroit fit a Sherman made in California. A replacement crew trained in Texas could immediately integrate with a unit that trained in Georgia. German logistics remained fractured. Different factories produced slightly different variants. Parts weren't always interchangeable. Replacement crews trained on one model often struggled with variations from different manufacturers. The endgame. April 1945. Kessel, Germany. The Henschel plant where Tiger tanks had once been built was now rubble. Allied bombing had destroyed the precision machinery required for German manufacturing methods. In American-occupied territory, field maintenance units were performing what German engineers would have called miracles, rebuilding tanks from hulks, cannibalizing damaged vehicles to create operational ones, keeping armor rolling through methods that prioritize speed over perfection. Hauptmann Weber, now a prisoner of war, was taken to tour an American maintenance depot. What he saw shattered his remaining illusions about German technical superiority. American mechanics, many of them barely trained, were working on dozens of Sherman tanks simultaneously. They were replacing engines in 2 hours, swapping transmissions before lunch, patching armor damage that German procedures would have required depot-level facilities to repair. "How?" Weber asked his escort, a tank lieutenant. "Systems thinking. We don't make our tanks perfect. We make them repairable by anyone with basic tools and training. We don't make our maintenance difficult. We make it so simple that teenagers can do it in a field under fire. But the quality is good enough. That Sherman over there has been knocked out 3 times. We've rebuilt it 3 times. It's got parts from 4 different factories, a turret from a tank that burned up, an engine from one that threw a track, and transmission from one that took a mine. None of those parts fit perfectly. They don't have to. They just have to work."
The Reckoning. May 8, 1945. Victory in Europe. The final statistics told a story that German engineers would spend decades analyzing. American tank production, all types, 88,410 vehicles. German tank production, all types, 46,857 vehicles. American tanks repaired and returned to service, approximately 60,000. German tanks repaired and returned to service, approximately 8,000. The kill ratios told only part of the story. Yes, German tanks were superior in individual combat. A Panther could destroy multiple Shermans, but the Americans could replace those Shermans faster than Germans could destroy them, while German Panthers, once damaged, often never returned to battle. The real genius wasn't in the tanks themselves. It was in the industrial ecosystem that supported them. Factories that could produce them by the thousands,
supply chains that could deliver parts anywhere, maintenance units that could repair them in days, and a philosophy that valued adequate numbers over perfect individuals. The human element. Behind every statistic was a human story. Mary Henderson, the former secretary turned welder, had helped build 423 tanks during her service at Kaiser. Margaret Sullivan, the assembly line worker, had made over 175,000 welds on Sherman hulls. Raymond Morrison, the maintenance sergeant, had rebuilt 67 tanks from damaged hulks. These people weren't master craftsmen. They were ordinary Americans who became components in an industrial machine that overwhelmed German precision with American volume. On the German side, the human cost was equally profound. Klaus Hauptmann, the engineer who had praised Tiger quality in 1939, survived the war to watch American mass production techniques revolutionize German industry in the 1950s. Everything he had believed about craftsmanship versus quantity had been proven wrong. Hauptmann Weber returned to Germany in 1947. He became an industrial engineer, applying American production techniques to rebuilding German manufacturing. "We were fighting the last war," he later wrote. "We built museum pieces. They built weapons. We lost before the first shot was fired because we didn't understand that modern war is won by factories, not craftsmen." The revolution. The Sherman tank wasn't revolutionary because of its design. It was revolutionary because of how it was built, maintained, and employed. The Germans never understood that the revolution wasn't in the vehicle, but in the system. American engineers had achieved something that seemed impossible. They had industrialized craftsmanship itself. They had taken tasks that required years of training and broke them into steps that required days. They had transformed quality from an individual achievement to a statistical measure. They had made excellence repeatable by making it systematic. This wasn't just about tanks. It was about a fundamental reimagining of how industrial democracies could wage war. The Americans had discovered that 1,000 adequate weapons produced quickly would defeat 100 perfect weapons produced slowly. They had learned that maintenance capability mattered as much as initial quality. They had understood that logistics determined strategy more than tactics did. The legacy. Today, modern military production follows American principles, not German ones. Modular design, field-replaceable components, statistical quality control, rapid production cycles all trace their origins to Sherman tank production in World War II. The Germans eventually learned these lessons. Post-war German industry, rebuilt with American assistance, adopted American production philosophies. The German quality that became famous in the 1960s and beyond was actually American production methodology applied with Germanic thoroughness. The lesson was clear. In modern warfare, the nation that can build adequate weapons faster will defeat the nation that builds perfect weapons slowly. The nation that can repair damaged equipment quickly will outlast the nation that requires perfect repairs slowly. The nation that prioritizes systematic capability over individual excellence will overwhelm those who worship craftsmanship. Friedrich Weber, the Panther commander who couldn't understand why American tanks kept coming back, later summarized it perfectly. "We built the best tanks in the world. They built a tank system that was better than any individual tank. We brought craftsmen to an industrial war. They brought industry. We never had a chance." The day German tankers discovered that American welders could outbuild their best engineers wasn't a single day. It was a slow, terrible realization that spread across 3 years of combat. Every time a Sherman they'd destroyed returned to battle.
every time their own damaged tanks sat immobilized for weeks, every time American maintenance units performed impossible repairs overnight. By the end, they understood. The Americans hadn't just won through numbers, they'd won through a fundamental reimagining of how modern war was fought. Not tank versus tank, but system versus system. And in that contest, German perfection had been buried under American adequacy multiplied by industrial scale. The welders of Detroit, the assembly line workers of Michigan, the maintenance sergeants working under fire in Belgium, these were the people who defeated German armor, not because they were better craftsmen, but because they were components in a system that was better than any individual could be. That was the revolution German tankers never understood until it was far too late. By the time they realized that American welders were more dangerous than German engineers, the war was already lost. The mathematics were inexorable. The Shermans kept coming, kept being repaired, kept overwhelming German armor through sheer systematic superiority. And the Germans? They kept building perfect tanks that sat immobilized, awaiting parts that would never arrive, victims of a production philosophy that belonged to a bygone age.